Welcome to my video lecture series in Object-Oriented Programming. This is Professor Janice Raymond Tan from the College of Computing and Engineering.
For this video lecture, we will cover the topics about inheritance. Throughout this video, we will discuss what is inheritance, the types of inheritance, constructors and inheritance, initializing the constructor of the superclass, inheritance and method overriding. What is inheritance? Inheritance is one of the significant features of an object-oriented programming language. This is a special feature as it reduces programmers' rewriting effort. Inheritance is an important pillar of OOP or object-oriented programming. It is the mechanism in Java by which one class allows to inherit the features, the fields, and the methods of another class. Inheritance in Java is a mechanism in which one object acquires all the properties and behaviors of a parent object. It is an important part of OOP. The idea behind inheritance in Java is that you can create new classes that are built upon existing classes. When you inherit from an existing class, you can reuse the methods and fields of the parent class. Moreover, you can add new methods and fields in your current class also. Important terminologies when dealing with inheritance are the following. Number one is superclass. This is the class whose features are inherited, and it is known as also as the base class or a parent class. Next one is subclass. The class that inherits the other class is known as subclass or a derived class, extended class, or child class. The subclass adds its own fields and methods in addition to the superclass fields and methods. Reusability. Inheritance supports the concept of reusability. An example, when we want to create a new class and there is already a class that includes some of the code that we want, we can derive our new class from the existing class. By doing this, we are reusing the fields and methods of the existing class. Inheritance represents the is-a relationship, which is known as a parent-child relationship. Inheritance can be defined as the procedure or mechanism of acquiring all the properties and behavior of one class to another. In example, acquiring the properties and behavior of child class from the parent class. This concept was built to achieve the advantage of creating a new class that gets built upon an existing class. It is mainly used for code reusability within a Java program. Moreover, a hierarchical order of management of information can also be done using this concept. Here, two types of classes build relationships with each other, which are a base class or superclass and derived class or subclass as shown in the given figure. The class that gets inherited taking the properties of another class is the subclass or derived class or child class. Again, the class whose properties gets inherited is the superclass or base class or parent class. The keyword extends used to inherit the properties of the superclass to subclass. In the terminology of Java, a class which is inherited is called a parent or superclass, and the new class is called child or subclass. So throughout our discussion, we will always refer to superclass and the subclass. The figure shows an example of inheritance as represented using the UML class diagram. The superclass is the person class that is why the arrowhead is pointing in its class, while the subclass or child class is the student class which points to the person class. Specifically, the diagram shows that every student is a person, that is the is-a relationship. Person class is the superclass or parent class of the student class. Student class is the subclass or child class of the parent class or the person class. If the person or every person has first name and last name, Since a student is a person, it gets or inherits everything defined in its superclass or parent class. The first name, last name, and even the get full name method will be inherited. No person has an ID and course. In real world, a person should be a student to have an ID and course. Only a student has ID and course. The one who receives the first name and last name is the one who inherit. In our case, student class receives the first name and last name class fields. The person class will not be able to inherit ID and course since it is the super class or the parent class. Always remember, only the subclass will receive everything, the class fields, methods, or even constructors that is defined inside its superclass, and superclass will not receive anything from its subclass. Translating into code. As defined in the class diagram, person class has class fields such as first name and last name, both of the data type string having initial values of John and Doe. Observe the proper format inside the class diagram of defining initial values to class fields. Since the class fields already has initial values, and we will not allow for instance the user to set new values, only getters for first name and last name were defined, namely get first name and get last name, to make it a read-only class. Additionally, a method named getFullName is defined inside the person class, which returns a string containing the combined values of first name and last name separated by a space. As defined in the class diagram, student class has class fields such as ID and course, but since we used an arrow that points to another class in our case, the person class is pointed. The student class is now a subclass of the person class and will be able to receive the class fields such as first name and last name, including its getters and the method name getFullName, even without directly defining them inside the body of the student class. The way we do inheritance in the code is to use the extends keyword, followed by the name of the superclass or the class to be inherited that will be defined right after the name of the subclass. By doing so, creating an object of a student class and using the instance for printing the full name by calling the getFullName method is possible. By creating a main class, having the main method to run the program, we should produce an output as shown in the given figure. Now the question is, how is it possible that the student object named stud1 be able to access the getters and method of the person class? Well, that is because of inheritance. By using the extends keyword as defined in the student class, we are able to access everything that is defined in its superclass, which is the person class. And that is how inheritance works. Another question is it possible to make objects of the person class? Consider scenario 1. The given code is acceptable since we only access getters and method of the person class, which is the class we use to make an object. What will happen if we will try to access the getters of the student class using the person object? Consider the scenario 2. The error simply means that get ID and get course as getters of the student class, which is the subclass, are inaccessible if you want to use a person object as the reference, since the person class is the superclass, does not have the ability to receive anything from its subclass. Remember that. To effectively implement inheritance, the tip is all common fields and methods that can be shared by the subclasses should be identified and be defined in a superclass. Types of inheritance. Single inheritance happens when a single class gets derived from its superclass, wherein Class A is the superclass and Class B gets derived from that superclass. In the example given, Dog class inherits the animal class, so there is the single inheritance. When there is a chain of inheritance, it is known as multi-level inheritance. In this type of inheritance, a subclass gets created from another subclass and can have any number of levels. This shows the idea of having grandparent superclass, child subclass of the grandparent class, and the grandchild subclass of the child class. As you can see in the example given, baby dog class inherits the dog class, which inherits again the animal class. So there is a multi-level inheritance. When two or more classes inherits a single class, it is known as hierarchical inheritance. In this type of inheritance, there are more than one subclasses which get created from one single superclass. In the example given, dog and cat classes inherits the animal class, so there is hierarchical inheritance. Constructors and inheritance. Constructor of a subclass is invoked when we create the object of subclass. It by default invokes the default constructor of superclass. Hence, in inheritance, the objects are constructed top-down, meaning starting from the root class constructor down to its subclasses. The superclass constructor can be called explicitly using the super keyword, but it should be the first statement in a constructor. The super keyword refers to the superclass immediately above the calling class in the hierarchy. The use of the use of multiple super keywords to access an ancestor class other than the direct parent is not permitted. The class diagram shows an example of single inheritance. The superclass is the person class, that is why the arrowhead is pointing in this class, while the subclass is the student class which points to the person class. Notice that this is almost the same as the earlier example of inheritance. The only difference is this time we included constructors for both the person and student class having default and parameterized constructors. By translating this into code, we will be able to figure out how we could initialize the constructor of the superclass when creating an object of its subclass. As defined in the class diagram, person class has class fields such as first name and last name, and the only way to provide values to these values are class fields is through its parameterized constructor, which accepts first name and last name. That is why in the given code, we define non-parameterized and parameterized constructor. The getters for the class fields will be used for accessing the values for printing on the user's screen. As defined in the class diagram, student class has class fields such as ID and course, but since we use an arrow that points to another class, in our case, the person class is pointed, the student class is now a subclass of the person class and will be able to receive the class fields such as first name and last name, including its getters and method name get full name, even without directly defining them inside the body of the student class. By creating a main class having the main method to run the program, we should produce an output shown in the given figure. The output of the sample execution in the main method generates null or zero and zero values. This is because, as you notice, we use the non-parameterized constructor of the student class, which does not initialize values. That is why it is null and zero. So no first name, no last name, no full name, no ID, and no course. Since again, we use the non-parameterized constructor when creating a student. We will not be able to assign the values for a given student. Now consider changing the code under the main method. Using the parameterized constructor this time of the student class, which accepts first name, last name, ID, and course, we were able to initialize all the values from two different classes, the person and the student class. Using the super keyword as the first statement, Under the parameterized constructor of the student class, keep in mind that the use of super keyword to call the superclass constructor should always come first before any line of code in a subclass parameterized constructor. Inheritance and method overriding. Method overriding happens when we declare the same method with the same name in a child class which is already present in the parent class. So as you can see here, we have the public class, parent class. This will be our superclass. Inside our superclass, we have a constructor which prints constructor of parent and a method named display which prints parent method. Now, by using the extends keyword inside the child class definition, we will be able to access and inherit everything what is defined inside the parent class, considering the constructor of the superclass and its method name display. So, by using method overriding, it means that inside your child class, as you can see here, the display method inside the child class is the same name with the display method of the superclass. So by doing this, by defining a method name within a child class, the same name with the parent class method, you are doing method overriding, which means when you make an object of the child class and calling that display method using the child class object, instead of um, invoking the display method of the parent class, it will invoke the display method of the child class because you already overridden the method. So inside our display method here, so inside the child class, we printed child method, and we can also still call the method inside our parent class by using the super keyword. By using the super keyword, you are calling everything defined on your parent class. You can also call other methods which is not overridden. That is also possible by using the super keyword. In our case here, right after printing the child method using the display method of your child class, you are calling super.display, which means it will call the display method of the superclass which prints the parent method right after printing child method. So by creating a main class having the main method to run the program, we should produce an output as shown in the given figure. The output of the sample execution in the main method shows that by calling the display method of the student class, it overrides the display method of the person class. A requirement to do method overriding is to implement inheritance. It is not possible to do a method overriding without inheritance. By tracing the display method of the student class, it prints the child method, and by calling the display method of the person class, using the super keyword followed by the method name of the superclass, we are able to execute and print the parent method on user's screen. So that is how method overriding works. In summary, we could say that inheritance is an important pillar of OOP. It is the mechanism in Java by which one class is allowed to inherit the features, class, or the class fields and methods of another class. Inheritance represents the is-a relationship, which is also known as a parent-child relationship. Extends keyword is used to implement inheritance. Super keyword is used to access the constructor and methods of the superclass inside its subclass. Inheritance can be represented using UML class diagram. There are different types of inheritance, namely single, multiple, and hierarchical inheritance. Method overriding requires the use of inheritance. For this lesson's activity, um, follow the given instructions. So satisfy all the requirements, and you should be able to produce a specific output and able to post your output in our week 9 channel. So you should be able to also draw the UML class diagram of the program code. You should post a screenshot of your diagram created using the Amlet application and the link to your to your program working code using your account in codeva.io inside our post tab of week 9 channel of our MS Teams. So that's it for now. Thank you for watching and hope you enjoy this video. For inquiries, feel free to post your questions in our group chat. In our next video, we will discuss all about list of objects. Don't forget to visit the links in the references section for more information about this lesson. See you in the next video.